Hey everyone, and welcome. Today we're diving into something really cool, making GPUs way more energy efficient.
Yeah, it's not just about tech, it's got to be the future of computing,
You
right?
got it. We've got studies, announcements, even YouTube clips to figure out.
It's wild how a tiny tweak in a GPU's voltage really impacts energy use, you know? We miss those small things sometimes.
For sure. So why is this such a big deal?
Think about it. GPUs, they're power hogs, crunching tons of data. More demand means a bigger energy footprint.
Right, hitting costs, the planet, the whole shebang.
Exactly. So it's a race, powerful processors, but sustainable, not losing performance. Tricky balance.
Like a sports car sipping fuel, like a tiny scooter.
Haha, that's it. One trick is DVFS, dynamic voltage frequency scaling.
DVFS sounds complex. Is it brilliant or what?
Might be from the future, but it's pretty neat. It adjusts the GPU's voltage, its frequency, based on what you're asking it to do. Full power when needed, scales back to save energy when chillin'.
So giving it a coffee break when it's not, like full throttle.
You got it. Now, this is where it gets cool. Power use is tied to voltage squared.
Physics refresher needed here.
Basically, a small voltage drop means big energy savings. Cooler GPU, long-term difference.
Less voltage, less power, big impact. Makes sense. But there's got to be catches with this DVFS.
Oh yeah, no magic fix. Apps stress GPUs differently. Some are heavy calculations, others use tons of memory. We need like tailored DVFS for each.
Okay, so no easy button. Any real-world examples where it's working?
Actually, yeah, optimizing LiDAR data, that's a good one.
LiDAR, that's self-driving cars, right?
Yeah, tons of data, 3D point clouds to map everything, real-time processing, that's where GPUs shine.
So how do we make LiDAR efficient on a GPU then?
Data structures are key. How we organize info for the GPU. You'd think 3D structures for 3D data, right?
That sounds to me.
Seems that way, but 2D is way more efficient here.
Wait, seriously? Why is that?
LiDAR data is 3D, but it's kind of flat, you know? Like a super detailed map, not much height.
So 3D technically, but the details are like on a flat plane mostly.
Exactly. 2D structure uses less memory, processes faster, like cramming flat paper into a box for big stuff, wasted space, same idea.
Great visual. So we're cutting the GPU's workload, saving energy.
Exactly. Optimization matters. But let's talk NVIDIA, they're making waves.
NVIDIA, yeah, they're kind of a big deal in the GPU world. What are they up to?
So their new Blackwell architecture is a pretty big deal, especially for AI and data centers.
Blackwell, huh? Sounds kind of mysterious. What's the big deal with it?
It's all about better performance and using less energy. They've got this second generation transformer engine, right?
Transformer engine. Okay, that sounds serious. Does it live up to the name?
Oh, yeah. It's built for AI, especially those crazy calculations you need for, like, understanding language.
So AI gets smarter, faster, all that.
That's the goal. And to keep data moving, they've got NVLink, like a super fast connection between multiple GPUs.
So instead of one superbrain, it's more like they all work together.
Exactly. Bigger, tougher tasks, no problem. But here's the real kicker for energy efficiency. They added a decompression engine.
A what now? Decompression engine. Is that like unzipping files but faster?
Kind of. It makes processing data up to 8 times faster, but using 8 times less energy.
8 times faster, 8 times more efficient? That's insane.
Right. And on top of that, there's the RAS engine for reliability, availability, serviceability.
RAS. Okay, I'm going to need a breakdown on that one.
It's like the system's babysitter, always watching for problems, making sure it never crashes.
Built-in tech support never takes a break?
Pretty much. Might not seem like energy efficiency, but less downtime is less wasted energy.
Makes sense. Every little bit helps. But how does this Blackwell thing fit into those giant data centers?
It's huge for them. Data centers, they're the backbone of, well, everything online these days. And more they're switching to GPUs.
We talked about GPUs being powerful and all, but why not just stick with the usual CPUs?
It's how they're built. Totally different. CPUs, they're like the multitaskers, good at lots of things, one at a time. GPUs, they're all about doing tons of tiny things at the same time.
So CPUs are like the all-purpose tool, and GPUs are more specialized, but super good at what they do.
Nailed it. And what they do best is what we need now. AI training, big simulations, handling insane amounts of data.
Right, so for all this data stuff, GPUs are the way to go. Sounds like NVIDIA's all in on that with Blackwell.
Totally. They even have this new platform just for large language models, super energy efficient, the GB200 NVL2.
So GPUs for AI is the future. Feels like a turning point.
Could be.
It's a lot to take in, but for those of us who aren't like Coding whizzes, what's the real-world impact? How does this affect, everyday life?
It's easy to get lost in the weeds, yeah. But
Uh,
this stuff will be everywhere soon.
Hit me with some examples then.
Healthcare's a big one. Imagine doctors using these crazy efficient GPUs, analyzing like mountains of medical images, DNA, all that, way faster, cheaper too. We're talking quicker diagnoses, personalized treatments, maybe even curing stuff we thought was impossible.
So better healthcare, faster breakthroughs, that's huge. Anything else?
Tons. Climate modeling, imagine those super accurate predictions, but running on GPUs that sip power. It could be a game changer for tackling climate change, right?
Wow, so it's not just about speed, it's about solving big problems too. Anything else come to mind?
Remember those immersive experiences we talked about? Games, VR, all that. Energy-efficient GPUs could make them even cooler, more realistic, and way more accessible.
Feels like we're on the edge of something big, a whole new world, and it's all thanks to these little chips getting smarter and less power hungry.
Definitely. And as AI gets crazier, who knows what we'll see. Self-driving cars that are actually safe, learning that adapts to you, it's pretty mind-blowing.
It really makes you think, what will the world look like with all this power, but used responsibly? It's exciting, a future full of potential, but driven by innovation that doesn't cost the earth, literally.
Couldn't have said it better myself.
And on that note, we'll leave you with that thought. Thanks for joining us on this deep dive into the future of energy-efficient GPUs. Until next time.